Today we're going to talk about logarithmic functions, and sometimes you can think about the logarithm as the what power function or the what exponent function. So we'll start with sort of a little mnemonic, if you will, for remembering how to deal with a logarithm. So a logarithm is really just a special way to ask a specific question. And as I said in class over the past week or so, a logarithm is really an exponent. That's why we spent so much time reviewing all of the exponent rules. So if you're feeling confident and comfortable with your exponent rules, then logarithms are going to be pretty comfortable for you. So we'll start by how a log looks. Okay, and so usually you'll see log base b of a equals nx, whatever variable you like. Okay, and so again, that's read as log base b of a is x. Okay, so when you see, let's say, log base 2 of 8 equals 3, that's exactly how you would read it, and we'll look at some of those. Okay, so what's the question that you ask yourself when you see a logarithm? So the question is, what power is required to go from a base of b to reach a value of a? And some people use what they call the loop trick. So you're thinking b to the x power equals a. Okay, so some people think about it that way. B to what power, meaning the x, is equal to a. So what power is required to go from a base of b to reach a value of a? So the log is the exponent. Okay, so log equals x, and x represents the power or exponent. So log base b of a asks the question, what exponent is required to go from a base of b in order to reach a value of a? For example, if I have log base 2 of 8, that is basically asking what exponent is required to go from a base of 2 to reach a value of 8. So 2 to what power equals 8? Hence all the practice with 2 to some power, both in the problem sets and with the lesson 7 intro that we talked about. Okay, so 2 to what power? So that means our question mark is 3. So log base 2 of 8 equals 3. That says 2 to the third power equals 8. 2 raised to the third power equals 8. Okay, so your answer, log base 2 of 8, is 3. The exponent is your answer. Log base 3 of 81 means what exponent is required to go from a base of 3 to a value of 81. Log base 3 of 81 equals, we'll say x or question mark. So we're saying 3 to what power equals 81. And so you could rewrite 3 to the x equals and re-express 81 as 3 to the 4th power. And just like the lesson we did with getting the bases equal, now our exponents are equal. So that means your x is equal to 4. Okay, one of the first things we're going to do when we're dealing with logarithmic equations is to be able to convert back and forth between exponential form and logarithmic form. So similarly, in the last section, we wanted to be able to convert from exponential to radical form. Now we're going to take from exponential form to logarithmic and vice versa. Okay. So in exponential form, we have the base raised to the exponent equals an answer, right? So you have base exponent equals the answer. Okay. With the logarithmic form, you have log base answer equals exponent. There are lots of mnemonic devices I've seen for helping people to remember this. One that I've seen that people like is BASE. Okay, the B stands for the base, so it becomes the base of the exponential. A is the answer. S is the same, so that means you have an equal sign here, and then exponent goes in that position. So if that's helpful for you, you can use it. I've also seen people use BENE, B-E-N-E, and I'll talk more about that in class tomorrow. Okay, if you need to pause or stop and watch anything, then please go ahead and do that. All right, so we'll go ahead and start with exercise 1. And basically, in the first exercise, you're just converting from exponential form to logarithmic form. And then in exercise 2, you're going from logarithmic form to exponential form. Okay, so if I want to go from 3 to the 5th equals 243, that means the base of the exponent becomes the base of the log. Okay, the answer goes here, and the log is equal to the exponent. So if you want to fill in down below, a log is an exponent. So if that's helpful as you're remembering how to convert back and forth, then go ahead and use that. Okay. So I'm going to ask you to pause the video and go ahead and complete the remaining 4 boxes in exercise 1. And or you can wait until I finish going through exercise 2 and then pause and finish. Okay, exercise 2, we're going to switch forms. We're going to go from log form to exponential form. So if you wanted, you could use that loop trick that I mentioned, 9 to the 1 equals 9. You could use base of the exponential. A is your answer, equals stays the same, and 1 is your exponent. Or you can just think the base of the log becomes the base of the exponential. So if we look at the next one, the base of the log is 2, that's the base of the exponential. And then you're really thinking and kind of checking 2 to what power equals 512. So you want to make sure that once you convert to exponential form, it makes sense. 2 to the 512 wouldn't be 9, so it makes sense that it's 2 to the 9 equals 512. Okay, so again, I'm going to ask you to either pause here or wait until after we're done, and then you can go ahead and complete it. Okay, the last thing we're going to talk about is a common logarithm. Now, I know some of you in chemistry have already talked about common logs. A common log is just a log base 10. It used to be up until, maybe 5-ish years ago that the calculator could only do common logs base 10. But now, and I'll show you in class, we can get the calculator to do log base 2 of whatever, log base 3, log base 5. It used to be that they could only do base 10, okay? And I did say there would be a portion of your assessment that would be non-calculator, which is important to know how to use some of the properties. Okay, so we'll try one example in exercise 3, and then I'll let you complete the rest of the examples in exercise 3. So if I have log where there's no base written, the base is implied to be 10. So we're asking the question 10 to what power, right, because it's the what power function, is equal to 0.01. And this is where it could be helpful to use the rewritten form of that. So 0.01 is like 10 to the negative 2 power. So if you wanted, you could convert that so that you have 10 to the question mark equals 10 to the negative 2. And then that way you know that your answer for this problem will be negative 2. Okay, so I'm going to ask you to finish exercise 3 and finish 1 through 8, the examples on the bottom of this page. I'll see you all tomorrow.